Hello, friend. Welcome to Science for Sleep. Whether you are returning tonight or finding this quiet corner for the first time, this is a place to slow down, learn something gentle, and let the day gradually fall away. Tonight, we are exploring what cats really do after the human household settles. The lights dim, doors close, and familiar rooms become quieter. Some cats move to a window and watch the dark outside. Some pause beside a doorway, turn toward a wall, or walk across the bed just as a person begins to sleep. Others suddenly race down a hallway, stop without warning, and become still again. These actions can look random when we see only a few seconds of them. But the domestic cat, known scientifically as Felis catus, is not simply wandering through the night without a pattern. Its behavior is shaped by several systems working together. An internal clock affects when the body becomes alert. Large pupils and light-sensitive cells help the eyes use dim light. Movable ears detect sounds that fall beyond the upper range of human hearing. Memory helps the cat follow familiar routes through rooms, around furniture, and toward important places. Scent marks, hunting behavior, social attachment, and learned household routines add more information to every step. A cat may be fully fed and permanently indoors, yet it remains a small predator with the body and senses of a hunter. If you enjoy these quiet journeys, you are welcome to subscribe. And if it feels natural, to leave a comment sharing where you are listening from tonight. It helps others find this calm corner of science, one sleepy listener at a time. The nighttime cat is familiar enough to feel ordinary, but complex enough to be studied with tools that can follow it beyond human sight. Researchers can fit cats with lightweight global positioning system collars that record where they travel. Small motion sensors can measure movement in 3 directions. Animal-borne cameras can reveal whether a cat is resting beneath a shrub, watching another animal, crossing a road, or hunting something its owner will never see. Those tools have shown that the night of an indoor cat can differ greatly from the night of a cat allowed to roam outside. An indoor cat may organize much of its activity around electric lights, meal times, doors, and the movements of people. An outdoor cat may respond more strongly to weather, natural twilight, prey, rival cats, and the changing sounds of a neighborhood. Age changes the pattern as well. A kitten, a healthy adult, and a senior cat may sleep for different lengths of time, move through different distances, and react differently to darkness. Health can alter the pattern too, especially when a cat that was once settled begins pacing, calling, or becoming confused at unusual hours. Even the word nocturnal needs care. It means active mainly at night, and it is often used for cats because so much feline movement happens after sunset. Yet many cats are most active near dusk and dawn, the 2 periods when daylight is changing rather than completely absent. Biologists call that pattern crepuscular, meaning connected to twilight. Domestic cats are also flexible. They can shift portions of their schedule around food, human activity, artificial lighting, and access to the outdoors. So hunger alone cannot explain the early morning visit to the food bowl. Boredom alone cannot explain the fixed stare toward a doorway. Excess energy alone cannot explain why a cat returns to the same window at nearly the same hour. Each action may contain several causes at once. The cat may be awake because of its body clock, alert because of a faint sound moving along a remembered route, and heading toward a place connected with warmth, prey, scent, or companionship. That is the larger hidden life inside an ordinary nighttime walk. The home has not become empty when people go to sleep. It has entered a second shift, measured by softer light, smaller sounds, older instincts, and a clock that does not follow bedtime in quite the human way. Before we can understand what a cat does during those hours, we need to ask a more basic question. Does the domestic cat truly belong to the night, or only to the changing edges around it? Night is a broad word, and animal biologists divide daily activity into more precise patterns. A nocturnal animal does most of its moving, feeding, or hunting after darkness has settled. Many owls and bats follow that pattern closely. A diurnal animal is mainly active during daylight, as people usually are. Cats often fit best into a third group called crepuscular. Crepuscular activity is concentrated around twilight, especially near dawn and dusk, when daylight is changing. For many domestic cats, those two edges of the day create a bimodal rhythm. Bimodal simply means that activity rises twice during one daily cycle. One increase often appears in the early morning, and another develops during the evening. This pattern can be measured with a small accelerometer attached to a collar. An accelerometer records changes in movement, much like the sensor that lets a phone detect when it has been turned or lifted. In one study involving 28 pet cats, researchers tracked both movement and eating across different seasons. During summer, activity and feeding often rose between roughly 5 and 9 in the morning. A second rise appeared between about 8 and 11 at night. Those hours sit close to sunrise and sunset in the longer days of summer. Winter changed the pattern. Shorter daylight pulled activity closer to a narrower span around the available light. The cats did not all wake, eat, or roam at exactly the same moment. Each animal still carried its own habits, home conditions, and history. Even so, the group showed that feline activity can shift with the season, rather than remaining tied to one fixed clock time. Access to the outdoors made the difference clearer. Cats allowed outside showed a stronger two-peak pattern. Their movement followed natural changes in light more closely, along with temperature, weather, and the activity of animals around them. Rodents often become active during low light periods. Insects gather or move differently as daylight fades. Birds settle in the evening and begin calling again near dawn. For a small hunter, these changes can make twilight especially rich with information. Indoor cats live under a different set of signals. Electric lights may keep rooms bright long after sunset. Meals arrive according to a household schedule. A person may come home at 6 in the evening, play with the cat at 8, then prepare food before bed. Over time, those repeated events can shift when the cat becomes alert. The body still responds to changing light, yet daily routine adds another clock on top of it. Weather can reshape the rhythm as well. Rain may reduce outdoor movement. Cold temperatures can shorten a roaming period. Hot summer afternoons may encourage more rest until the air cools. A cat living in a quiet apartment may follow a different pattern from one living on a farm, even when both belong to the same species. Age, health, neuter status, available space, and the presence of other animals can all change the visible schedule. This flexibility helps explain why one cat sleeps through midnight, while another begins walking from room to room. The word nocturnal remains useful because cats often become active after sunset. Crepuscular gives a closer description for many of them, since dawn and dusk frequently matter most. Domestic life then bends that inherited rhythm around food, light, weather, and human routine. The result is a clock that responds rather than a clock that simply repeats. A cat waking before sunrise may be following the light-dark cycle, anticipating breakfast, listening to birds outside, or combining several of those signals at once. Its schedule can feel inconvenient from a bed nearby, though the pattern is biologically organized. Twilight tells us when feline alertness often rises. The deeper reason for those hours reaches back to dry landscapes, small prey, and a wildcat that lived beside human settlements long before the first modern home existed. The first cat clocks were shaped under open skies, rather than electric light. Domestic cats descend mainly from the African and Near Eastern wildcat, known scientifically as Felis libica. This animal still survives across parts of Africa and Southwest Asia. Its body looks familiar. The legs are fairly long, the frame is slender, and the coat is usually sandy grey with faint stripes. A wildcat may weigh only a few kilograms, yet it hunts with the patience of a much larger predator. Rodents make up an important part of its diet. Birds, reptiles, and insects can also become prey when the opportunity appears. Most hunts begin quietly. The wildcat listens from cover, approaches with the body low, then uses a short burst of speed near the end. Cooler hours make that strategy more practical in dry regions. Midday heat can raise the cost of movement and increase water loss. Near dusk, the ground begins releasing heat stored during the day. Air temperatures fall, shadows lengthen, and many small animals become active. Dawn creates another useful period before the full heat returns. Those conditions help shape the 2 daily activity peaks still seen in many pet cats. The history of domestication began when human life changed the landscape around these wild hunters. Agriculture expanded through the Near East roughly 10,000 years ago. Communities began growing wheat, barley, lentils, and other crops in larger amounts. Harvested grain could be stored for months inside baskets, clay containers, or built rooms. That stored food attracted mice. A settlement containing several grain stores could support far more rodents than the surrounding dry land. Wildcats followed this concentrated prey toward people. Their arrival created a useful exchange without requiring formal training. The cats found reliable hunting grounds. People gained help protecting food that had taken an entire season to grow. Tolerance became valuable on both sides. A wildcat that fled at the first human sound would lose access to the rodents. One that stayed near walls and storage areas could continue hunting. People were also more likely to accept animals that remained calm nearby and reduce the number of pests. This process unfolded slowly across generations. No single village created the domestic cat on one exact date. Different populations moved toward human settlements at different times, and later trade carried cats far beyond their original range. One remarkable piece of evidence comes from Cyprus. At a site called Shilourokambos, archaeologists uncovered a human burial beside the remains of a cat. The burial is about 9,500 years old. Cyprus lies in the eastern Mediterranean Sea. Wildcats were not native to the island, so people must have carried at least some cats there by boat. That journey happened thousands of years before written histories described household pets. It suggests that cats had already become important enough to transport across open water. Ancient DNA adds a wider view. Researchers have examined genetic material from more than 200 cat remains found across Europe, Africa, and Southwest Asia. The results support an early spread connected with farming communities from the Near East. A later expansion was strongly associated with Egypt. By roughly 4,000 years ago, Egyptian paintings showed cats beneath chairs, beside people, and taking part in hunting scenes. Some images place them in marshes where birds were being caught. Others show cats inside the home, close enough to appear as familiar members of the household. Ports and ships then helped carry them farther. Grain vessels had the same problem as land-based storehouses. Food cargo attracted rodents, and a small hunter could protect valuable supplies during long journeys. Cats traveled along coasts, through trading cities, and eventually into regions their wild ancestors had never occupied. Through all of this movement, the hunting system remained largely intact. Sharp hearing still located small prey. Low-light vision continued to support activity near twilight. The body remained capable of stalking, pouncing, and resting between short bursts of effort. Human settlement created a new ecological niche, which means a new place in the environment where an animal could survive and reproduce. The wildcat entered that niche by doing what it already did well. Over time, greater tolerance allowed the animal to remain near people without surrendering the private rhythm that had guided it across dry landscapes. That ancient schedule still rises inside the modern home. Domestication added another layer, because the cat gradually learned to fit its inherited clock around lights, meals, footsteps, and the daily habits of humans. Inside a modern home, sunrise and sunset share control with many newer signals. Electric lights can brighten a room hours after darkness arrives outside. A phone alarm may sound before dawn. Heating systems switch on, doors open, cupboards move, and familiar footsteps begin crossing the floor. Each repeated event can help shape when a cat becomes alert. Biologists sometimes call an outside timing cue a Zeitgeber. The word comes from German and means time giver. A Zeitgeber helps reset or steady the body's internal clock. Natural daylight is one of the strongest examples. Light entering the eyes sends information to brain systems that organize sleep, movement, body temperature, and hormone release across roughly 24 hours. A cat near a window may therefore respond to the gradual brightening before sunrise, even while the room remains quiet. Indoor life adds several learned signals to that natural cycle. The sound of an alarm may predict that a person will soon move. Footsteps toward the kitchen can predict a cupboard opening. The cupboard may predict a food container, followed moments later by breakfast. After enough repetition, the earliest part of that chain can begin producing alert behavior. A cat may lift its head when the alarm sounds because the entire sequence has become familiar. This kind of learning is called association. The animal connects one event with another because they repeatedly occur close together. Food can create especially strong anticipation. Researchers use the phrase food anticipatory activity for movement that rises before an expected meal. A cat may leave its resting place, walk toward the feeding area, vocalize, or watch the person who normally prepares the food. The meal has not arrived yet, but its usual time and surrounding cues already carry meaning. Social contact can have a similar effect. A person returning from work may bring conversation, play, access to another room, or a place on the couch. The sound of a particular vehicle outside or a key entering the lock can become part of the cat's daily schedule. Shelter studies have also recorded feline activity rising when lights switch on and staff enter the room. Those observations require care because the light and the people often arrive together. Researchers cannot always tell how much each signal contributes when both occur within the same few moments. The combined event still shows how strongly a managed environment can organize behavior. A free-roaming cat may remain closely tied to twilight, prey movement, temperature, and weather. An indoor cat often shifts more of its activity toward the hours when people are awake and available. The ancient rhythm remains underneath, while the household supplies additional timing marks. Learning can also turn a natural early morning awakening into a lasting routine. A cat may become alert near dawn because of its circadian system. Circadian refers to biological patterns that repeat across about one day. Suppose the cat meows beside the bed at 5 in the morning. A sleepy person eventually gets up and fills the bowl. The food strengthens the behavior that came before it. This process is called reinforcement. Reinforcement makes a behavior more likely to happen again because it produced a useful result. No deliberate training session is required. After several successful mornings, the cat may begin arriving earlier, calling longer, or adding a paw against the blanket. Human responses have quietly become part of the timing system. The same process can develop around bedroom doors, nighttime attention, or play. A scratch at the door may lead to access. A soft call may bring a hand from beneath the blanket. Repeated outcomes teach the cat which actions work in that particular home. This creates a shared schedule built from biology and experience. Light sets broad periods of readiness. Meals and social events give certain hours greater value. Past results guide the behaviors used when those hours arrive. The cat's night therefore develops partly through life with the people around it. Its clock can bend toward work schedules, weekend mornings, seasonal light, and the exact time dinner usually appears. That flexibility depends on a sleep pattern very different from the long, uninterrupted block most humans hope to receive. A cat can adjust to the household because its rest is divided across many smaller periods of sleeping and waking. That flexible schedule is possible because feline sleep is spread across the full day. Most humans prefer one long period of sleep at night. Cats usually divide their rest into many shorter episodes. Scientists call this pattern polyphasic sleep. Polyphasic means that sleep happens in several separate periods instead of one continuous block. An adult cat may rest on a chair during the morning, wake for food, sleep again in the afternoon, become active near dusk, and return to rest later that night. Across 24 hours, adult cats are commonly reported to sleep or rest for about 12 to 16 hours. That range needs a little care. A cat lying still with its eyes partly closed may be quietly resting without being fully asleep. Many observations combine those two states because they can be difficult to separate without measuring brain activity. Individual totals also change with age, health, temperature, activity, and the safety of the surroundings. Kittens often sleep for longer periods while their nervous systems, muscles, and bones are developing. A senior cat may also spend more time resting because movement has slowed, or because joint pain makes active periods shorter. Illness can increase tiredness, while some age-related conditions can disturb sleep and create more waking at night. Even healthy sleep contains several different states. During light sleep, the body relaxes while the cat remains easy to wake. The ears may turn toward a sound. A small movement nearby can cause the eyes to open within seconds. This kind of sleep is useful for an animal that hunts small prey, while remaining small enough to face danger from larger animals. A wildcat resting near brush or rocks benefits from conserving energy without becoming completely unaware of its surroundings. Deeper sleep develops when breathing slows and the body becomes less responsive. This stage belongs to non-rapid eye movement sleep, often shortened to non-REM sleep. The brain still remains active, though its electrical patterns differ from those seen during waking. Physical recovery, immune activity, and other forms of body maintenance continue during these deeper periods. Rapid eye movement sleep creates a different pattern. The eyes move beneath the closed lids, and brain activity becomes more similar to waking activity. Large skeletal muscles lose much of their normal tension. This temporary reduction in muscle tone is called atonia. Atonia helps keep the body mostly still, while the brain passes through an active sleep state. Small movements can still appear. Whiskers may tremble, an ear may flick, or one paw may move briefly. Those twitches do not prove that the cat is dreaming about a particular bird, toy, or hallway. They only show that the sleeping nervous system is active. French neuroscientist Michel Jouvet helped reveal this system during the late 1950s and early 1960s. Working with cats, Jouvet studied a brain region called the pons, which lies low in the brain near the brainstem. His experiments helped establish the connection between rapid eye movement-like brain activity and the loss of normal muscle tone. He called this state paradoxical sleep because the brain appeared active while the body remained deeply relaxed. The word paradoxical describes two features that seem as though they should not occur together. Feline sleep therefore shifts through changing levels of awareness and muscle activity. A cat may spend part of the night in light sleep, enter a deeper stage, pass through rapid eye movement sleep, then wake and check the room. After rising, it may stretch the spine and hind legs. Grooming often follows, helping clean the coat and settle the body after rest. A short walk toward water, a window, or another room can come before the cat curls up somewhere else. This cycle may happen several times while a person nearby remains inside one long sleep period. Waking at 2 in the morning does not mean the cat has failed to sleep. Its recovery has already been divided across many earlier hours. Polyphasic sleep leaves several openings for feeding, movement, social contact, and environmental checking. When the eyes open in a darkened room, the cat still needs enough information to move safely. Its first advantage comes from an eye built to gather the small amount of light that remains. The room may be dark enough that a person can barely separate a chair from the wall. A cat still needs some light to see it. Vision begins when tiny packets of light called photons enter the eye. When no photons are present, no eye can form an image. Cats therefore cannot see in complete darkness, even though they move with remarkable ease in dim rooms. Their advantage begins at the pupil, the dark opening in the center of the eye. Bright sunlight causes the pupil to narrow into a thin vertical slit. That narrow shape limits the amount of light entering and protects the sensitive tissue farther inside. As evening deepens, muscles in the iris allow the pupil to widen. The iris is the colored ring around the pupil. In low light, a cat's pupil can become broad and nearly round, opening a much larger path for the remaining light. Moonlight through a window may then provide useful visual information. A faint glow beneath a door can help as well. After passing through the pupil and lens, light reaches the retina at the back of the eye. The retina is a thin layer of nerve tissue containing cells that react to light. Two important types are rods and cones. Rod cells work especially well when light is weak. They help detect movement and broad changes in brightness. Cone cells need more light and contribute more strongly to color vision and fine detail. A feline retina is built heavily around rods, which suits an animal active near dawn, dusk, and the darker hours between them. This design allows a small movement near the floor to stand out even when the object itself is difficult to identify. A moth crossing a pale wall may appear more clearly than a toy that remains perfectly still. The feline eye also contains a reflective structure called the tapetum lucidum. The name comes from Latin words meaning bright tapestry. It sits behind the retina. Some incoming light passes through the retina without being absorbed on its first trip. The tapetum reflects part of that light forward through the light-sensitive cells again. This second pass gives the retina another opportunity to collect information from the same small amount of light. The reflection also creates eye shine. When headlights, a flashlight, or an outdoor camera points toward a cat, light enters the eye and returns toward the source. The glow often appears green or yellow. Blue-green shades are possible as well. Its exact color changes with the angle, the kind of light, and differences within the eye. Dogs and deer also possess a tapetum lucidum. Raccoons use the same general structure during their nighttime activity. Each of these mammals benefits from gathering dim light during at least part of its daily life. The reflected glow can look bright in a photograph, though the cat does not experience its own eyes as glowing lamps. Eye shine is light returning outward after it has already entered. This system brings a trade-off. Reflected light can scatter as it travels back through the eye. That scattering may reduce the sharpness of the image. A human in good daylight can often see fine edges and small details more clearly. The cat gains greater sensitivity in dim conditions while accepting a softer picture. Color also becomes less useful as the light fades. Research indicates that cats can distinguish some colors, especially within blue and yellow ranges, but their color experience is narrower than ours. At night, contrast and motion carry greater value. A hallway may therefore appear as broad surfaces with useful edges and patches of different brightness. The lower edge of a door remains visible. A table leg breaks the shape of the floor. Nearby, a small shadow shifts against the baseboard. Memory supplies much of the familiar layout, while the eyes gather fresh information about anything that has changed. The cat can move through this softer picture because perfect detail is unnecessary. A hunter waiting near cover needs to notice the brief motion that signals opportunity. The visual system has already gathered the remaining light. Its attention now turns toward the part of the scene that refuses to stay still. That shifting detail can command far more attention than a large object sitting perfectly still. The eyes collect light and the brain decides which parts of the scene deserve a response. For a cat, movement carries urgent information. A chair may fill a large part of the room, yet its familiar shape has remained unchanged for hours. A moth crossing the wall creates a new pattern within a fraction of a second. The nervous system gives that change priority. This sensitivity fits the hunting life of a small predator. Mice rarely travel through the center of an open space for long. They follow walls, move beneath plants, and slip through narrow gaps where their bodies remain partly covered. Small birds shift among branches. Beetles disappear beneath leaves and emerge somewhere nearby. A cat that notices movement along an edge has a better chance of detecting prey before it vanishes. The same preference remains inside a modern home. A baseboard forms a long border beside the floor. The dark space beneath the couch provides cover. Door gaps create narrow openings where light, scent, and movement can pass between rooms. Curtains produce changing edges when air from a vent moves the fabric by a few centimeters. These places attract attention because they resemble the roots and hiding spaces used by small animals. Contrast helps the movement stand out. Contrast means a visible difference between nearby parts of an image. A pale insect crossing a dark curtain creates strong contrast. A darker shape passing over a bright wall can have the same effect. At night, a porch light or passing vehicle may send a reflection slowly across the ceiling. The light changes direction as the vehicle moves along the street. A cat may follow that reflection with its head, even though the source remains outside and far away. Color provides less information under these conditions. Cats can distinguish colors, especially within parts of the blue and yellow range, though their color vision is narrower than human vision. Dim light also reduces the usefulness of color for any eye. Shape, brightness, and motion become more valuable. This helps explain why a cat may ignore a colorful toy lying still, then become intensely focused when the toy shifts beneath a blanket. Familiarity makes small changes easier to detect. A cat that has crossed the same room hundreds of times carries a memory of its usual layout. The table legs stay in expected positions. The doorway keeps a familiar shape. A curtain normally hangs along one line beside the window. When an insect appears on the ceiling or a cord begins to sway, the new detail interrupts that stored pattern. The difference may be tiny, yet the room is already well known. A long stare toward a wall can therefore have an ordinary cause. A small spider may be moving near the ceiling. The shadow of a branch may be shifting under an outdoor lamp. A faint reflection can slide over painted plaster and disappear. Sometimes the cat has also heard a sound or detected a scent near the same location. Its eyes may face one point, while the ears adjust by a few degrees. The nose continues sampling the air during the pause. The visible stare can be the final result of several senses narrowing attention toward the same area. This kind of stillness belongs to ambush hunting. An ambush predator waits until movement enters a useful distance. Remaining motionless reduces noise and helps prevent prey from noticing the hunter. The muscles stay prepared beneath the quiet body. Pupils remain wide in the low light. Whiskers may angle forward as attention sharpens. The pause can continue for several minutes when the target is hidden or moving slowly. During that time, the cat is actively collecting information. A sudden pounce may follow, though many observations end without one. The insect can disappear into a crack. A reflection may fade when the vehicle turns a corner. The cat may decide that the signal no longer deserves energy and simply look elsewhere. Its attention has still served its purpose. The visual system found a biologically useful change and held it long enough for the brain to evaluate. That quiet process explains many of the moments people describe as mysterious. Some signals remain beyond vision altogether. A cat can turn toward an event that has produced no visible movement because the night also reaches it through sound. A room can feel silent because human hearing has reached its limit. Sound still travels through it as pressure waves moving through air, floors, walls, and furniture. The number of vibrations made each second is measured in hertz. 1 hertz means 1 vibration per second. A low hum contains relatively slow vibrations. A high squeak contains many more. Young humans are often able to hear frequencies approaching 20,000 hertz or 20 kilohertz. 1 kilohertz equals 1,000 hertz. Sensitivity near that upper boundary usually declines with age, so many adults hear a narrower range. Cats extend much farther into high-frequency sound. In a classic controlled hearing study, researchers measured feline responses from approximately 48 Hz to 85 kHz. 85 kHz means 85,000 vibrations each second. The exact limits depended on sound level and testing conditions, yet the study revealed a hearing range far above the usual human ceiling. This sensitivity suits an animal that hunts mice and other small prey. Rodents produce ultrasonic calls, meaning sounds above 20 kHz. Mice use some of these high frequencies during courtship, social contact, and distress. Movement also creates brief sounds as claws touch dry material or a small body passes through grass. A cat does not need to understand every signal as communication. Detecting the sound can be enough to reveal that a living animal is nearby. The visible outer ear helps gather that information. This part is called the pinna. Its curved surface catches sound waves and guides them toward the ear canal. Muscles around the pinna allow a cat to turn each ear toward a source. One ear may angle toward a faint noise near the window, while the other remains directed toward the hallway. These movements can occur while the head and body stay almost completely still. Direction becomes clearer because sound reaches the two ears differently. A noise coming from the left usually arrives at the left ear slightly earlier. It may also sound louder there because the head partly blocks its path to the right ear. The brain compares those differences in arrival time and loudness. Frequency changes caused by the shape of the ears provide additional clues. Together, these signals allow the cat to estimate where the sound began. A brief scratch beneath furniture may produce a small turn of the ears first. The head follows once the location becomes clearer. Eyes then settle on a floor edge, wall gap, or dark opening where movement might appear. Night changes the acoustic character of a home. Human voices and footsteps become less frequent. Traffic often decreases. A small sound that competed with daytime activity can stand out more clearly. Rain touches glass with uneven taps. Air passes through a vent and moves a loose cover. Water cools inside plumbing after a faucet has been used. Wood, metal, and plastic contract slightly as temperatures fall, sometimes producing a click or creak. An insect may strike a lampshade. A mouse inside a wall can disturb insulation or brush against a hidden surface. Outside, a distant gate closes, or a bird shifts in a shrub before dawn. The cat receives only part of this information. Sound becomes weaker as it travels, and walls block some frequencies more effectively than others. Age changes hearing as well. Older cats may lose sensitivity, especially at higher frequencies. Ear infections, wax, injury, or inherited deafness can reduce what an individual animal detects. A blue-eyed white cat, for example, has a higher risk of congenital deafness because genes affecting coat color can also influence structures within the inner ear. Even a healthy cat does not hear every faint event in every room. Its advantage comes from a broad frequency range joined with ears that can search for direction. That system turns many tiny disturbances into usable locations. The sudden head turn, therefore, begins before anything appears in sight. A sound has reached the ears, the brain has compared both sides, and attention has shifted toward one small part of the room. Hearing can guide the cat close to the source. The final approach through dim space depends on touch, balance, and a sensitive field extending around the face and forelegs. As the cat approaches the source of a sound, its attention moves from the wider room to the space directly around its body. The long hairs extending from the muzzle are called vibrissae. Most people simply call them whiskers. Cats commonly have about 24 prominent muzzle whiskers, with roughly 12 on each side of the face. They usually grow in horizontal rows, although the exact number and arrangement vary between individuals. Each whisker is thicker and stiffer than an ordinary strand of fur. The visible shaft does not contain a nerve. Sensation begins deeper in the skin, where the whisker sits inside a specialized follicle, surrounded by nerve endings and a rich blood supply. When the shaft touches a chair leg or bends against the edge of a box, that movement pulls on tissue around the follicle. Sensory nerves convert the mechanical movement into electrical signals. Those signals travel toward the brain, carrying information about the direction and strength of the contact. This process is called mechanoreception. The word refers to the detection of physical forces such as pressure, bending, and vibration. Whiskers, therefore, provide close-range information when an object is too near the face for the eyes to inspect easily. A cat reaching beneath a couch may push its muzzle forward, while the whiskers touch the hidden edges first. The same system helps near a partly open door, a narrow gap between furniture, or the rim of a dark container. Whiskers also grow above the eyes and along parts of the cheeks. Those above the eyes can trigger protective blinking when something comes close. Shorter groups near the face add information from angles the main muzzle whiskers may not cover. Another set appears on the backs of the front legs. These are called carpal whiskers because they grow near the carpus, the joint area that compares roughly with the human wrist. They may contribute information when the cat holds a toy, reaches into a narrow opening, or brings an object close to the forelegs. Their exact role is still studied, so they should be understood as part of the close contact system, rather than a perfectly mapped second set of eyes. Whiskers clearly detect contact and displacement. They may also respond when nearby movement disturbs the surrounding air, though claims that they provide a detailed radar-like picture go beyond what the evidence supports. Another common belief says that a cat's whiskers always match the widest part of its body. The relationship is not exact. Body size can change with weight, age, or pregnancy, while whisker length varies naturally. The whiskers can still help judge nearby clearance, without serving as a fixed measuring tape. Information also rises through the feet. The paw pads contain sensory receptors that respond to pressure, texture, and vibration. A hard floor feels different from carpet. A loose board can shift slightly beneath one paw. Movement from a small object may travel through a surface before the object comes into view. As each foot lands, another system called proprioception tells the nervous system where the legs and joints are positioned. Proprioception allows the cat to place a rear paw near the earlier position of a front paw without watching every step. It also helps during climbing, crouching, and landing. Balance comes partly from the vestibular system inside the inner ear. Tiny fluid-filled structures detect changes in head position, turning, and acceleration. When a cat jumps onto a bed or changes direction in a hallway, this system helps the brain track how the body is moving through space. The tail and trunk then make small adjustments that keep the body stable. A nighttime walk brings all of these systems together. The eyes supply broad edges from the remaining light. The ears keep track of the original sound. Whiskers register close contact, while the paws report each surface beneath the body. Proprioception guides the limbs, and the inner ear helps preserve balance through every turn. Memory fills in the familiar route where fresh sensory information is incomplete. The movement may appear effortless from across the room. Under the fur, the nervous system is continually measuring contact, body position, sound, and motion. These tools explain how a cat can follow a path through darkness. The repeated choice of the same doorway, chair, and window belongs to a larger map built from memory and traces that remain after the cat has passed. The route through a home carries more than the memory of walls and furniture. It also holds a chemical record that remains invisible to human eyes. Cats produce scented material from several areas of the body. These include regions around the cheeks, chin, lips, forehead, paws, tail base, and rear body. When a cat presses its cheek against a doorway, some of that material can be left on the surface. A slow rub along a chair leg may add more. Contact with a person or another cat can transfer scent in the same quiet way. The chemicals come from small glands associated with the skin. Their exact mixture can vary with the gland, the individual cat, and its physical condition. A cheek rub can serve several purposes at once. It may occur during a friendly greeting, while the cat investigates an object, or as it adds familiar scent to a well-used route. No single explanation fits every rub. The behavior becomes clearer when it is viewed as part of a larger chemical landscape. Scratching adds another layer to that landscape. The claws leave visible lines in wood, cardboard, fabric, or bark. The action also stretches muscles through the shoulders and back. Old outer claw sheaths can loosen during the movement, revealing a sharper layer beneath. Glands associated with the paws may deposit scent near the scratched area as well. A scratching post beside a doorway therefore carries marks that can be seen and chemical traces that a cat can investigate. Some of these chemical messages are described as pheromones. A pheromone is a chemical signal that carries information between members of the same species. Cats may use such signals in social contact, territorial behavior, reproduction, and responses to familiar surroundings. Pheromones form only one part of the smell inside a home. Every cat also has an individual odor shaped by skin oils, saliva, fur, diet, health, and the places where it rests. People contribute skin cells and traces from soap, clothing, shoes, and outdoor air. Food leaves its own compounds behind. Cleaning products can cover older smells for a time, while fabrics slowly collect new material again. The household odor becomes a changing mixture rather than one simple feline message. A familiar blanket may carry detergent, human scent, and material from the cat's coat. Freshly washed bedding removes much of that older mixture. The new smell can cause a cat to sniff carefully, circle, rub, or choose a different place until the surface becomes familiar again. A suitcase arriving from a trip may carry traces from a hotel room, a vehicle, pavement, and unfamiliar buildings. Visitors bring their own skin products, clothing odors, and outside contaminants. Moved furniture changes the expected position of both objects and scent. Even a person returning from work can smell different after hours spent among other people and places. The cat samples these changes through the main smelling system in the nose. Certain chemical compounds can also be examined through a second pathway called the vomeronasal organ. This small sensory structure lies within the nasal and oral region. It connects with brain areas involved in social and reproductive behavior. A cat investigating a strong or unusual scent may lift its head and partly open its mouth. This expression is called the flamen response. The upper lip may rise slightly, while the cat pauses for several seconds. During that moment, air and dissolved chemical material can reach openings associated with the vomeronasal system. The expression may look like surprise to a person watching nearby. Its purpose involves chemical examination. Urine marks, glandular secretions, and scents left by other cats can all encourage this kind of response. Each investigation adds current information to an older memory of the territory. The cat learns which objects smell familiar, where another animal has passed, and whether a person has returned carrying something new. Chemical traces fade, become covered, or are refreshed through contact. The map therefore changes even when every piece of furniture remains in place. A doorway may hold material from repeated cheek rubbing. A favorite chair collects fur and skin oils during sleep. The floor near a window can receive outdoor scent whenever air enters through a screen. These traces turn the home into an archive that is continually read and rewritten. Once that chemical history is added to sight, touch, and memory, the repeated path from bed to doorway and onward to the window begins to resemble a quiet inspection of known territory. The chemical map becomes most useful when the cat begins moving through it. A familiar nighttime route may pass through a sleeping area, follow the edge of a hallway, and continue toward food, water, or a window. The same cat may stop near a scratching surface, climb onto a raised perch, or pause beside a closed door. These movements can look like wandering, although they often follow paths learned through repetition. Spatial memory allows an animal to remember where important places are located and how they connect. A cat can learn the position of its water bowl even after the room becomes dark. It remembers which chair provides access to a shelf and which doorway leads toward the litter box. Repeated journeys build a dependable picture of the home inside the brain. Animal behavior researchers often describe a territory through several useful features. A core area is a place the animal uses often, such as a favored sleeping room or a quiet corner near trusted people. Travel routes connect important parts of that area. Resources include anything the cat regularly needs or values. Inside a home, those resources can include food, water, litter areas, resting places, hiding sites, scratching surfaces, observation points, and human companions. Boundaries mark places where access changes. A wall creates a firm physical limit. A doorway creates a boundary that may open or close. A window separates indoor territory from an outside area filled with movement, scent, and sound. Cats often move beside walls or furniture, rather than crossing the center of an exposed room each time. Edges provide clear visual guides and reduce the number of directions from which something unexpected can approach. Wild small cats use vegetation, rocks, and uneven ground for similar reasons. Cover allows movement while keeping part of the body protected. Inside, the side of a sofa or a line of cabinets can serve as a dependable route through open space. Elevated places add another kind of security. A shelf, cat tree, windowsill, or the back of a couch can improve the view across a room. Height also reduces the number of directions from which another animal can arrive. A cat resting against a wall on a raised platform may need to watch only the open area in front and the path leading upward. Hiding locations provide the opposite advantage. A box, covered bed, or space beneath furniture limits visibility, while offering shelter from disturbance. The cat's route can connect these secure places with essential resources. Doorways deserve special attention because they gather several kinds of information in one narrow location. Sound travels through the opening from the room beyond. Airflow carries scent beneath and around the door. People and animals usually enter through the same limited space. Light changes when the door moves. This makes a doorway an information bottleneck, meaning many signals pass through one small area. A cat may pause there because the location provides a quick sample of what is happening elsewhere in the home. A closed door changes more than the shape of the hallway. It removes access to part of a previously available territory. The cat can still hear sounds through the barrier and smell air moving beneath it, yet the usual route has been interrupted. Sniffing the gap, waiting nearby, or touching the door with a paw may help gather information about the missing space. Previous success also shapes the response. A cat that once caused a door to open by scratching may repeat the same action later. Nighttime movement can therefore combine several purposes within one route. The cat may check a food bowl while passing through the kitchen. A stop near the bed can provide social contact or confirm that a familiar person remains nearby. Sniffing a doorway updates the chemical map. Climbing to a perch improves the view before the cat settles again. Exploration and learned habit can appear within the same journey. The word patrol offers a useful description for this repeated movement, as long as it is used carefully. The cat does not need to believe it has been assigned the job of guarding the home. Its route emerges from spatial memory, changing sensory information, access to resources, and the results of earlier trips. A familiar path can therefore remain stable, while small details along it change from night to night. Many of those routes eventually lead toward one especially active boundary, where the known indoor territory ends against a pane of glass. At the edge of the room, the cat reaches a place where its territory continues through information rather than movement. A window keeps the body indoors while allowing part of the outside world to enter. Through sealed glass, the cat can watch branches move, follow passing headlights, and notice animals crossing the ground. Some sound also passes through, especially lower tones and sharp impacts. Direct scent flow is greatly reduced because the glass blocks the moving air that carries odor molecules. A screened opening creates a richer border. Outdoor air can pass through the mesh, bringing changes in temperature and humidity, along with traces from soil, plants, food, vehicles, and nearby animals. Sounds arrive more clearly as well. The cat may hear claws on a fence, wings near a light, or leaves shifting beneath a small animal. An enclosed balcony or outdoor cat structure offers a different experience again. These spaces are sometimes called catios. A catio allows direct contact with outdoor air, while keeping the cat inside a protected frame of wire, wood, or screening. The available information changes with the type of boundary, even when the view covers the same yard or street. Artificial light can make the area especially active after sunset. Many moths and other insects gather near porch lights, street lamps, or illuminated windows. Their reactions vary by species. Some circle the light, while others land nearby or avoid strongly lit areas. Researchers are still studying why artificial lights disrupt insect navigation. Though many insects normally use distant natural light sources to maintain direction, a lamp only a few meters away creates a very different angle as the insect moves, which may interfere with that system. The insects then become moving targets for a cat watching from inside. Larger visitors may appear at predictable hours. Raccoons often search for food after dark. Mice can travel along walls, fences, or garden edges where cover is nearby. Crepuscular animals may pass close to dawn or dusk, while truly nocturnal species are more active during deeper darkness. Birds begin shifting in shrubs before sunrise. In a rural area, the same window might overlook a field used by rabbits or small rodents. A city apartment may offer balconies, rooftops, alleys, and lighted streets instead. Repeated activity helps explain why a cat returns to one window at nearly the same time each evening. Insects may gather after an outdoor lamp switches on. A neighbor may walk a dog along a fixed route. Garbage collection, delivery vehicles, or people returning from work can produce regular movement and sound. The cat learns these patterns through experience. A quiet window at midday may become highly informative at 9 in the evening. Glass also creates visual effects of its own. When the room is brighter than the outdoors, the surface can reflect furniture, lamps, and the cat's face. Those reflections may overlap with the scene beyond the pane. A moving shape outside can therefore appear among faint images from inside the room. The cat's eyes must sort through both layers. Weather changes the border from one night to the next. Rain adds tapping sounds and moving lines across the glass. Wind carries branches through changing arcs and pushes outdoor scent toward or away from a screened opening. Humidity can strengthen some odors by helping scent molecules remain near damp surfaces. Cold air may reduce insect movement, while warm evenings can bring more activity near lights. Another cat can transform the window very quickly. The visitor may cross a yard, sit beneath a balcony, or pause beside the building. The indoor cat may begin watching with a rigid body and widened pupils. Vocalization can follow, including low growls or sharper calls. Some cats rub nearby surfaces or scratch more often. After seeing an unfamiliar animal, Urine marking may appear when the outside cat repeatedly approaches the home. Defensive behavior can also be redirected toward a nearby person or pet. This is called displaced aggression. The arousal begins with a target outside, but the physical barrier prevents direct contact, so the response may fall upon something closer. Even without conflict, the window provides meaningful activity. Watching requires attention, memory, and careful tracking. The cat can follow movement and judge distance while remaining physically separated from the animal beyond the glass. The chase cannot be completed, yet the early parts of hunting may already be underway. Attention has narrowed, the body has grown still, and the muscles are preparing long before any pounce begins. The body begins changing before the paws leave the floor. A moving insect, a shifting reflection, or the edge of a blanket sliding across a bed can draw the cat's head toward one point. The ears turn first in some cases. The eyes settle on the target, and the whiskers may angle forward as the cat gathers more detail. This first stage is called orientation. Orientation means that the senses and body line up towards something that may be worth following. Domestic cats are ambush predators. They rely on concealment, patience, and a short burst of speed rather than a long pursuit across open ground. That strategy suits prey such as mice, small birds, lizards, and insects. A mouse often moves close to a wall or beneath cover. Its path includes sudden stops and sharp changes in direction, which create exactly the kind of movement a feline visual system notices well. Once the target has been located, the cat may watch without moving for several seconds or several minutes. The approach can begin with ordinary walking. As the distance closes, the body often lowers. Shoulders move smoothly beneath the skin, while each paw is placed with care. This slower part is stalking. A stalking cat reduces noise and keeps its outline low, allowing it to move closer before the target reacts. The sequence can then shift quickly. A target that runs may trigger a chase. When the distance becomes short enough, the cat pushes hard with the hind legs and pounces. The front paws reach forward to grasp. Claws extend to improve grip, and the mouth may close around the target. After capture, a cat can bite, kick with the hind feet, release the object, or move it with the paws. Researchers describe this as a predatory sequence made from separate behavioral parts. It is also a sensory motor chain. Sensory information from sight, sound, and touch guides motor actions produced by muscles and joints. The chain remains flexible. A cat may watch a moth without approaching. It can stalk a toy, pounce once, then walk away. During play, one part may repeat several times, especially chasing or batting. Hunger changes motivation, although a full stomach does not remove the hunting system. Predatory behavior can begin when movement and opportunity provide strong enough cues. A toy mouse does not need to be mistaken for a living animal. Its size, motion, texture, or disappearance behind furniture can activate pieces of the same sequence. A feather moving unevenly across the floor supplies quick changes in direction. A ball rolling beneath a chair briefly vanishes from sight, which encourages the cat to approach the edge and search. Reflected light moving along a wall can trigger watching and pursuit, even though nothing solid can be caught. Blanket folds also create cover, especially when a foot or toy moves beneath the fabric. The cat's body is built for the sudden movement that follows. During running, the spine flexes and extends. This movement allows the back to shorten and lengthen with each stride, increasing the distance covered by the feet. Large muscles around the hips and hind limbs generate much of the force for acceleration and jumping. The claws usually rest within protective folds of skin above the toes. When muscles pull on tendons, the final toe bones change position and the claws move outward. They can then grip carpet, wood, fabric, or the surface of a captured object. Soft paw pads reduce the sound of each step and help create traction during landing. As the cat turns, the tail shifts position and helps the body manage balance. The inner ear also reports acceleration and head movement, allowing rapid corrections before the paws touch down. A pounce that lasts less than a second therefore depends on preparation that began much earlier. The eyes selected a moving detail, the brain estimated distance, and the muscles waited until the opportunity became useful. Nighttime play carries this ancient structure into a home filled with safe substitutes for prey. At times, the carefully aimed sequence loses its single target and spreads through the whole body, sending the cat racing through rooms as the same arousal fills the house. A cat can shift from complete stillness to full-speed movement within a few seconds. The head rises, the pupils widen, and the hind legs press against the floor. A moment later, paws are crossing the hallway at speed. The cat may turn around a chair, leap onto a low surface, then stop as suddenly as it began. Animal behavior specialists sometimes call this a frenetic random activity period. Frenetic means fast and highly excited. Random describes the visible route, which may include abrupt turns and repeated sprints without one obvious target. The behavior still has causes inside the body and the surrounding environment. Cats and dogs both show these short periods of intense movement. Young animals often display them more frequently, although healthy adults can continue throughout life. The feline version fits a body designed for brief acceleration. Domestic cats hunt mainly through waiting, close approach, and sudden attack. Canids, such as wolves and many wild dogs, are better suited to traveling or pursuing prey across longer distances. A cat usually spends its greatest effort within a much shorter window. Powerful hind limbs start the sprint. The flexible spine lengthens each stride, while the tail and inner ear help control sharp turns. An indoor home can provide a surprisingly effective running course. A long corridor creates a clear straightaway. Rugs improve traction under the paws. Furniture forms corners, and an open doorway allows the route to continue into another room. Some cats circle the same group of objects several times because the layout supports quick turning. Stairs add climbing and rapid changes in height. The timing often connects with the cat's natural activity rhythm. A cat that has rested through much of the afternoon may become more alert as evening light fades. Movement outside a window can raise arousal. Play with a person may activate chasing and pouncing. The sounds of food preparation can add expectation, especially when dinner normally arrives at a certain hour. Several signals can meet within a short period and prepare the nervous system for action. Reduced activity during the day may also contribute. An indoor cat with few chances to climb, stalk, explore, or chase can experience a mismatch between its behavioral needs and the opportunities available. That mismatch explains some nighttime running, though many well-exercised cats also have zoomies. Twilight timing, social excitement, and the simple pleasure of fast movement can produce the same result. The common idea of stored energy works best as a loose expression. The body does store usable chemical energy in molecules such as glycogen and fat. Zoomies do not develop because energy has filled the cat like air inside a sealed container. The behavior appears when brain circuits controlling arousal and locomotion become active enough to recruit the muscles. Timing, stimulation, expectation, and available space all influence that activation. A playful chase may begin with a toy and continue after the toy has been left behind. Once the cat is highly aroused, running itself can become rewarding. Fast movement provides strong signals from the muscles, joints, skin, and balance organs. The cat may sprint, pause briefly, then repeat the route while that state continues. Many owners also report a burst of running immediately after the litter box, especially following defecation. The exact cause has not been established. Possible explanations include physical relief, a brief rise in arousal, or a learned habit that has repeated over time. Rapidly leaving the elimination area may also reflect an older tendency to move away from concentrated scent. Current evidence does not support one explanation strongly enough to settle the matter. Most familiar zoomies are brief and end with the cat returning to ordinary behavior. A sudden new pattern of pacing, agitation, or nighttime calling in an older cat deserves separate attention because pain, illness, or changes in the brain can also alter activity. The usual household sprint remains a normal display of a short burst movement system, responding to the right conditions. From the bedroom, the sound may arrive as quick pause and one soft thump from another room. The person listening is already part of the event. Human schedules influence when the cat rests, receives food, and becomes excited. The sleeping body itself also holds warmth, familiar scent, and a secure place within the cat's nighttime map. After the sprint ends, the cat may return toward the bedroom at a much slower pace. The sleeping person has become one of the most stable landmarks in the home. For several hours, the body remains in roughly the same place. Breathing follows a steady rhythm, familiar scent collects in the bedding, and warmth spreads into the mattress. A cat can learn all of these details. Studies show that cats can distinguish a familiar human voice from unfamiliar voices. They also learn the sound of recurring footsteps, the timing of daily movement, and the places where particular people usually rest. At night, that knowledge gives the bedroom a special value. Human core temperature stays near 37 degrees Celsius. The skin is cooler and varies with the room, the body part, and how much fabric covers it. Even so, a sleeping person and the surrounding blankets create a warmer surface than many parts of the room. Bedding also holds heat after the person shifts position. A cat settling near the knees or feet may be choosing a small warm zone that remains comfortable for a long period. Scent adds another layer. Sheets and pillows collect material from skin, hair, soap, and laundry products. The cat may add fur, saliva from grooming, or glandular material from rubbing. Over time, the bed develops a familiar chemical mixture connected with rest and safety. The visit can also be social. Attachment studies have found that many cats use a familiar caregiver as a source of security in an unfamiliar setting. Researchers still debate how closely feline attachment matches the patterns described in human children or dogs. the broader finding remains useful. A familiar person can change how confidently a cat explores, settles, or responds to stress. Closeness does not always require direct contact. One cat may sleep across a person's legs. Another may choose the foot of the bed, where warmth and scent remain available without much movement nearby. A chair beside the bed can offer social proximity with more personal space. Some cats rest beneath the bed using the same room while keeping cover overhead. Others prefer a hallway, another room, or a closed bed of their own. Each choice reflects the individual animal. Temperament matters, along with early social experience and previous handling. Age and health can shift the preference. A senior cat with stiff joints may seek a warm surface but avoid climbing onto a high mattress. A nervous cat may remain nearby while choosing a protected corner. Room temperature and household noise also change which location feels comfortable. Routine can make the visit more predictable. A cat may learn that the bedroom door closes at 10, the lights go out soon afterward, and the person remains available until morning. That sequence turns the room into a dependable part of the nightly schedule. Past consequences then shape what the cat does after arriving. Suppose an early visit begins because the bed is warm. The cat steps onto the blanket, receives gentle petting, and settles. Repeated nights strengthen the approach because contact follows it. A different cat may vocalize near dawn and cause the person to rise. Breakfast arrives several minutes later. The original awakening may have come from the cat's body clock, yet the human response can teach a more specific routine. Speaking, opening a door, or moving toward the kitchen can reinforce the behavior. Even a frustrated response may provide attention if attention is valuable to that cat. This makes nighttime interaction a shared system. The cat brings its inherited rhythm, sensory needs, and individual preferences. The person adds warmth, access, and a history of responses. Together, those factors give the sleeping human a place inside the cat's map. Affection may be part of the visit, especially when the cat chooses relaxed proximity and returns over many nights. Warmth or habit can contribute at the same time. The meaning often comes from several causes working together. One cat and one person already create a detailed nighttime pattern. When another cat shares the same home, roots overlap, familiar scents mix, and access to the sleeping human becomes part of a larger social arrangement. The arrival of a second cat changes the nighttime map immediately. Resources now have to be reached around another moving body, and every familiar surface carries an added chemical identity. Some pairs develop a close social bond. A friendly approach often begins with the tail held upright, sometimes with the tip gently curved. The cats may touch noses for a brief scent check, then rub their heads or bodies together. This contact blends odors from glands around the face and skin. Socially compatible cats may sleep close enough for their coats to touch. They can also groom one another, especially around the head and neck where self-grooming is more difficult. Scientists call this allogrooming, meaning grooming directed toward another member of the same species. Visible closeness represents only one form of peaceful living. Cats that rarely touch can still share a home successfully by keeping distance and dividing access through time. One may use a windowsill during the evening, while the other visits it after midnight. A favored chair can belong to different cats at different hours. This time sharing reduces the need for direct confrontation. The layout of the home strongly affects how well that arrangement works. A wide room offers several routes around another animal. Narrow passages concentrate movement into one small space. Doorways and staircases can become social bottlenecks because one cat may block the only easy path through. The same problem can develop around a litter area, food station, or favored perch. A cat waiting quietly in a hall may influence the other cat's movement without hissing or making physical contact. The second animal may pause, turn back, or delay visiting a resource until the route becomes clear. Outside the home, social spacing spreads across much larger areas. An unfamiliar cat near a property edge can trigger watching from a window, scent investigation, or vocalization. Calls exchanged at night may sound intense, yet they can provide useful information before physical contact occurs. Each animal can judge direction, distance, and the willingness of the other to remain nearby. Growling and drawn-out yowling may allow one cat to withdraw before a fight begins. Scent marking adds information that lasts after both animals have moved away. Urine sprayed against a vertical surface can advertise recent presence. Cheek rubbing and scratching leave quieter traces along well-used routes. Reproductive biology can increase these nighttime signals. Domestic cats are seasonally polyestrous long-day breeders. Seasonally polyestrous means that an unspayed female can enter several fertile cycles during part of the year. Long-day breeder means that increasing hours of light help support that cycling. In the Northern Hemisphere, reproductive activity often rises from late winter through warmer months as daylight lengthens. A female that does not become pregnant may return to heat approximately every 14 to 21 days, although timing varies between individuals. During heat, she may become restless, vocalize more often, rub against objects, and seek access outdoors. Males detecting her scent may roam farther or call near the area. Artificial lighting can blur the natural season. Exposure to roughly 14 hours of light each day can support continued cycling in some indoor females. A home lit from early morning until late evening may therefore provide a very different reproductive signal from natural winter daylight. Neutering greatly reduces many hormone-driven behaviors. Roaming commonly decreases, along with mate-seeking calls and urine marking. Social habits and territorial responses can remain because learning, personality, and resource access continue after reproductive hormones are reduced. A neutered cat may still watch an unfamiliar visitor, defend a preferred resting place, or avoid another household cat in a narrow hall. The night now contains several overlapping systems. Familiar companions may share scent and sleeping space. Less closely bonded cats can preserve peace by dividing routes and time. Outdoors, reproductive signals and territorial information spread beyond walls through sound and odor. Once those signals pull a roaming cat away from the house, its path becomes long enough to record with satellites and draw across an actual map. Once a cat passes beyond the doorway, its nighttime route can be measured instead of guessed. For many years, owners knew only that a cat left home and later returned. Lightweight global positioning system collars changed that. These collars record a series of locations using signals from satellites. When the points are placed on a map, they reveal repeated paths through yards, alleys, fields, roadsides, and neighboring properties. Researchers use the term home range for the area an animal uses regularly. A home range is wider than a single route and does not automatically mean the cat defends every part of it. Within that larger area, there is often a smaller core use zone where the animal spends more of its time. Scientists commonly estimate a broad 95% utilization area and a tighter 50% core area. The percentages describe how much of the recorded use is contained within each mapped boundary. An occasional excursion may extend beyond both areas. A cat might cross a road, enter a field, or follow another animal farther than usual, then return to its familiar routes. Large citizen science tracking projects have shown that many owned cats stay surprisingly close to home. Their ranges often cover only a few hectares. 1 hectare equals 10,000 square meters, about the area of a square measuring 100 meters on each side. A home range of 3 or 4 hectares can still include several gardens, sheds, fences, and quiet strips of vegetation. From a bedroom window, that space may seem small. At ground level, it contains many separate paths, hiding places, scents, and encounters. Most tracked pet cats in these studies remained near the home. A smaller number traveled much farther, with some ranges exceeding 1 square kilometer. 1 square kilometer contains 100 hectares. Those wide-ranging individuals can cross several streets or move deep into nearby farmland, woodland, or open space. Urban and rural cats often differ. Dense housing, busy roads, fences, and high cat numbers can limit movement in towns and cities. Rural cats usually have access to larger fields, barns, hedgerows, and lower density roads. Their home ranges tend to be wider, though the pattern varies with the individual animal and the surrounding landscape. Age can influence how far a cat travels. Sex and sterilization matter as well, especially when mate seeking affects movement. Nearby prey, the number of competing cats, housing type, and access to cover all shape the route. A major road can act as a barrier for one cat, while another crosses it repeatedly. 2 animals living on the same street may therefore produce very different maps. Daily distance also needs to be separated from home range size. A cat can travel several kilometers by repeating loops inside a fairly small area. In one controlled comparison lasting 21 days, cats with access to an outdoor enclosure moved about 4.29 kilometers per day. Cats kept indoors in the same study moved about 2.33 kilometers per day. Those figures describe total movement across the day. They do not mean that either group traveled 4 kilometers away from home. A cat pacing the same rooms, climbing, returning to a window, and circling familiar furniture can accumulate distance without expanding its territory very far. GPS maps bring hidden movement into view, but they do not explain every stop. A line can show that a cat spent 12 minutes behind a shed. The collar cannot reveal whether the animal rested in cover, watched a mouse, met another cat, or listened beside a wall. A cluster of points near a hedge may represent hunting, shelter from rain, or repeated scent investigation. To identify what happened at those locations, researchers need another kind of evidence. That missing layer would eventually come from small cameras and motion sensors carried by the cat itself. Those instruments add behavior to the lines already drawn across the map. A global positioning system collar records where a cat was and when it reached that location. The data may show a 5-minute stop behind a garage or a quick crossing between two gardens. Location alone cannot separate resting from stalking. The same cluster of points might represent feeding, a meeting with another cat, or shelter beneath a hedge. Owner observations leave even larger gaps. A person sees the cat depart through a door and may find a mouse on the step several hours later. Everything that happened between those moments remains hidden. Small cameras worn around the neck began to reveal parts of that missing time. The lens follows the direction of the cat's chest, rather than providing a perfect view through its eyes. Even so, the footage can show an approach toward prey, an attempted pounce, and the moments after a capture. Researchers can distinguish a failed hunt from a successful one. They can also record whether prey was eaten outdoors, abandoned where it was caught, or carried back to the household. That distinction changed estimates of hunting behavior. Camera-based research found that only about 23% of captured prey was brought home. A mouse or bird placed near the door therefore represents only part of the total for some roaming cats. Other captures may be consumed or left outdoors, where the owner never sees them. Motion sensors provide a different layer. A triaxial accelerometer measures movement along 3 axes. One axis records motion from side to side. Another follows movement forward and backward, while the third detects vertical change. Together, those measurements create a changing movement signature as the cat walks, rests, runs, or performs another activity. Recent studies have divided accelerometer records into segments only 1 second long. Computer models then search those brief segments for patterns linked with known behaviors. This process is called machine learning. The computer receives examples that researchers have already labeled, then learns which combinations of movement most often match each category. One model classified 8 feline behaviors with an overall accuracy of about 73%. That level can reveal broad patterns across many hours of recording. It also leaves room for error. 2 behaviors may produce similar movements at the collar. A cat lowering its head to sniff can resemble another short, quiet action. Fast play may overlap with part of a hunting sequence. The model assigns the most likely label without directly understanding the event. Combining tools reduces some of those uncertainties. Global Positioning System data places the cat behind a shed at 9:14 in the evening. An accelerometer shows a shift from walking to very little movement. Video may reveal the cat crouched beside vegetation while watching something beyond the frame. Each instrument converts one part of the night into data. Their records become more useful when location, movement, and visible behavior can be matched by time. The equipment also creates limits of its own. A collar must remain light enough for the cat to carry comfortably. Even a small camera or tracker may alter movement, catch against vegetation, or cause the animal to groom around it. Batteries restrict the number of hours recorded. Satellite signals weaken beneath roofs, dense branches, or beside tall buildings. A camera can point toward the ground during an important event, and darkness may hide details beyond the reach of its sensor. Missing locations leave breaks in the route. Small studies can also overrepresent a few unusually active hunters. Researchers must account for incomplete footage, individual differences, and the possibility that wearing equipment changes behavior. No instrument captures the entire night without loss. Still, these methods reveal far more than prey left on a doorstep ever could. They show attempted hunts that fail, captures that remain outdoors, and long periods of quiet behavior beyond human observation. Once those hidden captures are added to the ones people find at home, the activity of a single cat begins to connect with wildlife across an entire neighborhood. A single capture can seem small when viewed by itself. One mouse caught beside a fence or one bird taken beneath a shrub may disappear without any person knowing it happened. Repeated across many evenings and many cats living close together, those individual events begin to form a much larger pattern. Regular feeding reduces hunger while leaving the predatory system available. A cat may eat a complete meal indoors, then respond minutes later to the movement of a moth, mouse, or young bird outside. The hunting sequence begins through sensory cues. Quick motion catches the eye. Rustling near cover draws the ears toward one location. A short chase can follow because the nervous system recognizes an opportunity to stalk and capture. The food bowl and the hunt therefore meet different needs. One supplies nutrition. The other activates behavior shaped by millions of years of feline evolution. Researchers have tried to measure the effect by combining owner reports, tracking information, camera footage, and estimates of how many cats roam outdoors. One large tracking project recorded an owner-observed average of about 3.5 prey animals brought home by each roaming cat per month. That number describes only the prey people found. Cameras have shown that many captures never reach the doorstep. A cat may eat the animal where it was caught or leave it behind. Prey return counts therefore measure only a portion of total hunting for some individuals. The same research estimated local predation at roughly 14.2 to 38.9 prey animals per hectare each year. This measure describes density. It asks how many animals may be taken within a particular area rather than across an entire country. Local density matters because pet cats are often concentrated around homes. Several roaming cats may use the same group of gardens, hedges, and vacant spaces. Wild predators are usually spread more widely because each one must find enough food to survive. A fed domestic cat can continue hunting while receiving most of its calories from people. That allows a neighborhood to support more small predators than the available wild prey could support on its own. National estimates widen the scale further. Modeling in the United States has estimated that free-ranging cats kill approximately 1.3 to 4 billion birds each year. Estimated mammal deaths range from about 6.3 billion to 22.3 billion. Free-ranging includes owned cats allowed outdoors and cats living without a household. Unowned cats were responsible for most of the estimated deaths in those models because of their numbers and the amount of time they spend outside. Canadian estimates have placed annual bird deaths caused by cats between roughly 100 million and 350 million. Those ranges are wide because researchers cannot count every cat or observe every hunt. The final estimate depends on how many cats are assumed to roam, how often they hunt, and what proportion of prey is brought home. Habitat changes the calculation as well. A rural cat moving through fields encounters different prey from a cat using a city alley. Weather and season alter which animals are available. Researchers must then extend findings from a limited group of observed cats to a much larger population. This process is called extrapolation. Extrapolation uses measured data from a sample to estimate what may be happening across a wider area. The results carry uncertainty, yet the major studies point toward a substantial total effect. Islands and isolated ecosystems can be especially sensitive. Animals that evolved without small mammalian predators may nest on the ground or show little fear of an approaching cat. A population confined to one island also has fewer places from which new animals can arrive after losses occur. Introduced cats have contributed to serious declines and extinctions in several island ecosystems. Individual variation remains important throughout this picture. Many cats rarely bring home prey and may seldom complete a hunt. A smaller group can capture animals repeatedly and account for a large share of the total. Age, health, experience, roaming time, habitat, and individual hunting skill all affect the outcome. The ecological effect therefore grows from uneven behavior repeated across a high number of predators. The familiar animal returning quietly through a doorway remains one individual cat. Across a town, thousands of similar nighttime routes connect homes with nests, burrows, and feeding grounds. The outdoor landscape also places the cat inside its own field of danger, where roads, disease, larger predators, and toxic substances can turn the consequences in the opposite direction. Beyond the doorway, the hunter also becomes a small animal moving through a landscape filled with hazards. A domestic cat may hear a mouse beneath leaves and still fail to detect a vehicle approaching from farther down the road. Cars cover distance much faster than most animals can judge. Headlights change visibility. Wet pavement reflects glare. An engine sound may arrive from a direction the cat does not expect. A narrow street can become dangerous within seconds when parked vehicles block the view. Human structures create quieter risks. Garages and sheds may close while a cat is inside. Warm vehicle engines can attract animals during cold weather. Construction sites contain unstable materials, sharp objects, and openings that may later be sealed. Drainage pipes or enclosed spaces can become difficult to leave once entered. Fences sometimes trap a collar or leg, while storage rooms can hold a cat without food or water for hours or days. Other cats add infectious and physical danger. A confrontation may begin with staring and vocalization before becoming a brief fight. Canine teeth can drive bacteria deep beneath the skin. The small puncture at the surface may close quickly, trapping bacteria inside. Over several days, an abscess can form as pus collects beneath swollen and painful tissue. Deep bite wounds are also the main route, through which feline immunodeficiency virus spreads. This virus weakens parts of the immune system over time. Casual contact, such as sharing a room, carries much less risk than severe biting. Outdoor movement increases contact with parasites as well. Fleas can pass between animals or wait in protected resting places. Ticks attach in grass, brush, or woodland edges and may transmit disease depending on the region. Roundworms and other intestinal parasites can spread through contaminated soil or infected prey. A captured rodent may also carry bacteria, parasites, or toxic chemicals before the cat ever touches it. Larger animals change the risk according to place and body size. Coyotes can prey upon cats in many parts of North America. Loose dogs may chase or attack them near homes and paths. Foxes present a variable threat, while large raptors can endanger kittens or very small adults in some regions. Local wildlife matters greatly. A hazard common near a rural field may be absent from a high-rise balcony. and a city alley introduces dangers that open farmland does not. Toxic substances can enter the night without producing any warning sound. Antifreeze containing ethylene glycol has a severe effect on the kidneys. Even a small amount can cause life-threatening poisoning. Rodenticides create two routes of exposure. A cat may consume the bait directly, or it may catch a rodent that has already eaten poison. This second pathway is called secondary poisoning. Different rodenticides affect the body in different ways, including internal bleeding or damage to the nervous system. Weather continually reshapes the outdoor route. Cold increases the energy required to maintain body temperature. Snow can hide familiar scent marks and make movement more difficult. Heat raises the risk of dehydration, especially where shade and water are limited. Storms bring falling branches, sudden wind, and rapid temperature changes. Drought alters prey activity and can concentrate animals around the remaining water sources. Many outdoor ranges become smaller during poor weather or colder seasons, although individual cats respond differently. One may remain close to a porch during rain, while another continues along much of its usual route. Outdoor access also exists in several forms. A fully enclosed catio supplies air, changing light, and direct outdoor scent, while restricting contact with roads and roaming animals. Supervised time in a garden creates a different pattern of exposure. Unrestricted roaming allows the widest movement and places the cat within the greatest number of ecological and human-built systems. Each arrangement carries its own balance of stimulation, freedom, and risk. The cat's senses remain impressive throughout this landscape. Sharp hearing, rapid acceleration, and spatial memory help it navigate many dangers. They cannot remove vehicles, infections, toxic substances, or every larger predator. Nighttime waking and movement can still belong to an ordinary feline rhythm. Concern often begins when a familiar pattern changes suddenly, especially when a settled cat starts pacing, calling, or becoming confused in ways that were absent before. A familiar nighttime routine can remain stable for years before small differences begin to appear. An older cat that once woke briefly, drank water, and returned to bed may start walking through rooms for much longer. The cat may pause at a familiar doorway, as though the route has become uncertain. Calling can become louder or more frequent, especially after the household grows quiet. Normal feline sleep remains polyphasic throughout life, so waking several times at night can still be ordinary. Concern grows when the pattern changes from the cat's established baseline. Baseline means the usual behavior recorded across weeks, months, or years. New pacing, distress, house soiling, confusion, or repeated vocalization can carry information about changes inside the body. One possible cause is feline cognitive dysfunction. This condition involves age-related decline in brain function and is sometimes compared loosely with dementia in people. Possible signs include disorientation, altered social interaction, disturbed sleep-wake cycles, changes in activity, anxiety, vocalization, and elimination outside the litter area. A cat may become trapped behind furniture it once walked around easily. Another may stare toward a wall, seem uncertain on a staircase, or call after entering a dark room. Age-related behavioral changes are often reported after approximately 11 years. Age alone does not establish cognitive dysfunction. Many cats remain mentally capable well beyond that point, while illness, pain, or sensory loss can create similar behavior. Cognitive signs become more common in advanced age, especially as several body systems begin changing together. Veterinarians describe cognitive dysfunction as a diagnosis of exclusion. That means other likely causes must be investigated before the behavior is assigned to age-related brain decline. In one survey of cats diagnosed with cognitive dysfunction, owners frequently connected vocalization with disorientation or attention-seeking. Each explanation was reported by about 40.5% of respondents. Those owner interpretations describe what the behavior appeared to mean from outside. They do not prove the exact experience occurring inside the cat's mind. Several medical conditions can produce a similar nighttime picture. Hyperthyroidism is one important example. The thyroid gland sits in the neck and releases hormones that regulate how quickly the body uses energy. Hyperthyroidism occurs when too much thyroid hormone is produced. Some studied populations suggest that it affects roughly 10% of cats older than 10 years. A cat may lose weight despite eating more than usual. Restlessness, increased activity, a faster heart rate, and more frequent vocalization can also appear. Kidney disease may increase thirst and urination, causing repeated trips through the home. Urinary discomfort can lead to pacing, calling, or visits to the litter area. Pain from arthritis may make stairs difficult and prevent the cat from reaching a favored sleeping place. Hypertension, meaning abnormally high blood pressure, can affect the eyes, brain, kidneys, and heart. Neurological disease may interfere with movement, awareness, or learned routes. Anxiety can disturb sleep and increase attention-seeking, especially after a change in the household. Sensory decline changes the night in quieter ways. A cat losing hearing may vocalize more loudly because it can no longer judge its own volume accurately. Reduced vision makes dim rooms, stairs, and moved furniture harder to navigate. A familiar hallway can become confusing when visual landmarks fade. The cat may remain close to walls, hesitate at doorways, or call until a person responds. None of these behaviors identifies one diagnosis on its own. Their value comes from change across time. A single loud call may follow a dream, a closed door, or a request for attention. Repeated calls appearing alongside weight loss, confusion, altered appetite, pain, or house soiling carry a different meaning. Long familiarity allows a person to notice that difference. The nighttime pattern becomes a record of how the cat's clock, senses, comfort, and memory are functioning together. When that record changes, professional evaluation can help separate normal aging from treatable disease or deeper neurological decline. With ordinary waking distinguished from environmental danger and medical change, the quiet house can finally be understood as one complete system shaped by ancient rhythms, learned routines, sensory maps, and the people sleeping within it. When the house settles again, the cat may wake while the people around it remain asleep. It may lift its head toward a faint sound, walk along the edge of a room, pause at a window, and later return to the bed. A brief sprint may cross the hallway before the animal curls into another period of rest. Each familiar action now carries a clearer structure. The inherited clock of the domestic cat still leans toward dawn and dusk. That rhythm remains flexible enough to shift around electric light, meal times, human movement, weather, and outdoor access. Polyphasic sleep makes the adjustment possible because feline rest is divided into several episodes across 24 hours. The cat can wake, investigate its surroundings, and settle again, while a person attempts continuous sleep. Low light does not erase the room. Dilated pupils admit more of the remaining photons. A retina rich in rod cells detects movement, while the tapetum lucidum reflects light through the retina for another chance at detection. The picture remains well suited to a small hunter watching an edge. Sound widens that nighttime world. Frequencies far above ordinary human hearing can reveal insects, rodents, and subtle movement within walls or vegetation. Movable ears compare direction and intensity before the head turns. Closer to the body, whiskers register contact and bending. Paw pads report pressure and surface texture, while proprioception tells the nervous system where each limb is positioned. Balance organs in the inner ear help guide a landing or sudden turn. Scent gives those rooms a history. Cheek rubbing, scratching, bedding, shoes, and outdoor air continually alter the chemical layer spread across objects and passageways. Spatial memory connects that layer with the physical arrangement of resources. Food, water, litter areas, resting sites, doorways, perches, and people occupy learned locations. A repeated route can check several of them during one quiet journey. Predatory behavior also survives inside the household. A complete food bowl does not remove the response to prey-like motion. An insect near a lamp, a toy passing behind furniture, or a shifting blanket edge can activate orientation, stalking, pursuit, and pouncing. The sequence is flexible, so a cat may perform one part and abandon the rest. Play carries real biological continuity with the hunting behavior of its ancestors. Human companionship enters the same system through warmth, familiar odor, security, habit, and reinforcement. A cat sleeping across a person's legs may value several of those features together. Another may choose a nearby chair or the sheltered space beneath the bed. Attachment can remain strong across different preferred distances. Independence remains part of the relationship because the cat continues making choices through its own sensory map and experience. Indoor and outdoor nights share the same basic animal, though their conditions differ greatly. An indoor cat moves among rooms, windows, artificial schedules, and protected resources. A roaming cat may extend those routes across gardens, alleys, fields, or property edges. Global Positioning System collars reveal the geography. Accelerometers classify movement, and animal-borne cameras show behavior hidden between recorded locations. Those tools have exposed hunting that owners never see. Outdoor movement also connects the cat with wildlife populations, roads, disease, toxic substances, weather, and larger predators. Its abilities remain impressive without making the animal invulnerable. Regular waking, watching, moving, and returning can belong to a healthy feline night. A sudden change in that long-established routine may reveal pain, endocrine disease, sensory decline, or changes in the aging brain. Years of familiarity allow a person to notice when the rhythm no longer sounds the same. Thousands of years beside humans have changed where the cat lives and what surrounds it. Its anatomy and much of its behavior remain close to Felis libica, the African and Near Eastern wildcat that approached early farming settlements for rodents. The modern cat still carries a twilight hunter's eyes, ears, muscles, memory, and timing into bedrooms lit by alarm clocks and street lamps. Evolution, physiology, learning, territory, social relationships, and the immediate environment shape the hours together. The human night may feel like one long stretch of attempted sleep. The feline night arrives in smaller passages of resting, listening, watching, moving, and returning. Both unfold beneath the same roof, while the wildcat's ancient clock continues keeping time beside the sleeping human.